Hello guys, welcome back to VersaTube. So today I'm going to explain you all about the matrices and determinants weightage and roadmap to get into IIT by following my videos. So let's have a look at it. So here 2 to 3 questions in JEE mains and JEE advanced from matrices and determinants and 3 to 5 questions in MSET examination. MSET examination is state level examination in Telangana state, and also it can be appeared it can these questions may be appear up to 3 to 5 questions in all the state level examinations of entrance examination of engineering. So let's have a understanding of the concept very clearly about the determinants and matrices now. So this is the introduction. So we will go into the deeply into the introduction and the concept of matrices and determinants now. So let's have a look at it here. This is the determinants and matrices. Introduction to determinants. The determinant consists of 2 rows and 2 columns is D. D is equal to A1, B1. This is the determinant. So here 4 elements are present in this determinant. So its value is given by D equal to A1, B1. So here it is said to be as like this: A1 into B2 minus A2 into B1. So here this is the determinant. Determinant can be represented as like this. So it's the value of determinant. A determinant which consists of 3 rows and 3 columns is called a third order determinant and is of the following form. So if mainly for JE mains and JE advanced problems, there is only up to 3 cross 3 is given. Up to row and columns of 3 is given. That is that row by column equal to 3 by 3 or 3 by 2. It is given up to that only because you are in lower standards, uh, up to 12th. So in the engineering you can be given us like 4 into 5 by 4 by 5 matrix. In the engineering gate examination you will be given like that, but for JE JE mains and JE advanced you will be given up to 3 into 3 by 3 matrix. So it's the value, its value plus this will be here, first will be plus. So here it will be plus, it will be minus, it will be plus. A11 into A22, A33 minus A32, this one. First A11 into A22 minus A32. First this row, this column and this row will be erased and remaining will be multiplied cross sectional. So A22 into A33 plus A32 minus A23. So after that you will get the answers like this: determinant value equal to, by here also this one will be erased and this will be multiplied, this will be multiplied, and lastly we'll get the answer as this one. This is the determinant of the given matrix. So here next, minus and cofactors. Minus and cofactors, let delta equal to, delta represents the determinant of the matrix. So here delta equal to what here? So I have explained you, it is up from the above. So here this will be sent to this here. So Aij equal to element in first row, ith row and jth column of delta, minor of Aij. Aij means Aij. I can be equal to j or I cannot be equal to j. This is the definition of Aij. A can be, I can be of belonging to natural numbers. So I can belong to natural numbers and j can also be belonging to natural numbers. So it is defined as a value of determinant obtained by the eliminating the first row and the jth column of determinant. So we need to denote the minor of Aij by Mij. So here minor is represented by capital M. So in the DLE also it is there. In the gate examination also it is there, but you can understand this. It is only for, this video is only for IIT and JEE mains. So let's understand this in the point of view of JEE mains and JEE advanced and MSET. So cofactor of denoted by Cij. Cofactor is denoted by Cij and minor is denoted by Mij. So here minus is what here? So you should eliminate this row and this column and this row, and remaining will be cofactor, and its value will be cofactor. The value will be minor. Eliminate first row and first column and first row. You will getting the determinant, and its determinant is the minor of the given Aij. Aij is the element of the one element of the mat determinant. So next, cofactor of Aij. Cofactor of Aij is minus 1 power I plus j. I plus j minor of Aij. So here cofactor is what here? Cofactor is minus 1, minus 1 whole power 1 plus j. So here cofactor was denoted for determinant process. So it is a minus here. So it is minus plus minus. For determinant we got cofactor as like this. So here for cofactor of Aij, uh, Cij is cofactor equal to minus 1 whole power 1 plus I plus j. So here find cofactor of A12 is your homework. Comment down in the comment section if you got the answer. So next, here Aij equal to, I am doing it here. So see Aij A12 equal to Aij, I equal to 1, j equal to 2 here. So minus 1 whole power 3. 2 plus 1 equal to 3. So I wrote here 2. 3. Minor of Aij. Minor of Aij is what here? So minor of Aij is A12. A12's minor is what here? A21, A33, A21, A33, A31, A23. So here minus 1, A21, A31, A33. So negative will be multiplied to both the signs. A23 equal to A31, A23 minus A21, A33. So this is the cofactor of A12. So here you got two examples. You can easily understand what is the cofactor of Aij. So this is the explanation of cofactor. Next we're gonna see next evaluation of determinant. So here evaluation. So here value of any determinant can be obtained by adding product of all elements of a row or column to their corresponding factors. So here, so delta equal to what here? So delta can be equated as A11 into C11. So this one into this one, and here plus minus plus na. So here uh, cofactor is what here? Cofactor is minus 1 into this cofactor minor minus 1 whole power 1 plus 1 is 2. So this is this, and you will get the answer as this only, plus minus plus. This is a short form for finding out the determinant. uh, the long method is this one, the short method is this one. So you can use this short method for finding out the minors and determinant of the matrix in the JEE Mains and JEE Advanced examination. So properties of determinant. So here the value of determinant remains unaltered if the rows and columns are interchanged. So here if d equal to what here? If rows and columns are interchanged, the determinant won't be changed here. So determinant will be same, equal only if the rows and columns are interchanged also. If I am taking this as A1, A, this is A transpose. Determinant of A is what? Determinant of A is equal to determinant of A transpose equal to D. This is the property 1. This can be used in many problems. You can use this in many problems. I am going to explain the problems in next video. I am only explaining concept in this video. So here, if any two rows or columns of a determinant be interchanged, the value of the determinant changes in sign only. So here, see, if any two rows or columns of a determinant can be interchanged, the value of determinant changes in sign only. So here only two rows are changed here. What are the rows there? A2, A1, B3, row 1 and row 2 have been changed. The determinant. So it will be the sign of the determinant will be changed. Everything will be left unaltered. So this is the second property of the determinant. So next, if a determinant has all the elements 0 in a row or column, then its value will be 0. So if this will be 0, 0 into anything is will be again 0. So this if any of the row or column it will be a 0 row or 0 column, then it will be said to be as the determinant equal to 0. We couldn't after long method of evaluation also, you will get the same answer. But in short method you can directly write it as 0. I am explaining you how it get to equal to as 0. Next, we'll understand next property of determinants. So if a determinant has any two rows or columns identical or proportional, then its value is equal to 0. See here, without a k, it will be totally equal. So here, if the determinant in the determinant any two rows are equal or proportional, here k is a proportionality constant. Like this, it will be a1 proportional to a1. So a1 equal to k a1. So r1 equal to k r2. So here r1 equal to k r2. K can be for a1 equal to k a1, k equal to what here? K equal to 1. For r1 equal to kr2, kr2, the answer may be different. So here, so here r1 equal to kr2. So here it is proportional. R1 directly proportional to R2. This is the proportionality constant here. K is a proportionality constant. So next, if all the elements of row or column are multiplied by the same number, then the determinant is multiplied by the number. So here, if for any value, for any row or column, if a k or a constant is multiplied, so it can be multiplied outside directly. So here, then d complement equal to what here? D complement equal to kd. K is can be directly sent outside, and we can directly simplify it in the simplification format. We can directly calculate the determinant value. So here k, if k is sent to, k is a big number like 446 like that. If 446 is a big number, 446 into 1, 446 into 2, 446 into 3. So here 1 2 3 can be inside and 446 will be outside. So you can directly calculate the value of the determinant and directly write the answer as something. You get the answer, you can write it and multiply it with the k 446. So it's an example I have explained in this video. Next, if each element of any row or column can be expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. That is that a1 plus x, b1 plus y, c1 plus z. So here uh, you can, if a1 plus x, this is uh, this is you can easily multiply it. You can easily add it.